Hello guys, and welcome back to another episode of chemistry. And of course, in today's class, I'm going to be looking at some wonderful terms such as the electrode potential, electrode potential. I'm going to be looking at the concept of half cells, half cells. I'm going to be looking at EMF, electromotive force. Okay, we're going to look at salt bridge. Want to understand what a salt bridge is and how it can be made. Okay, and then learn some simple calculations. Okay, on how to calculate when it comes to electrochemical cells. For example, this is a question from the O3 Schools JAMB app, a 2018 question, model 1, number 11, which says, it's been shown on your screen right now. They say an electrochemical cell is symbolically represented as Zn/Zn2 plus. Okay, and then you saw something like this, like Zn/Zn2 plus. And then you now saw something like this. This is a salt bridge. This is what we call a salt bridge. So I'm going to look at it so that we do not deal with this question now. So this kind of questions you'll be seeing, okay, in this topic. Okay, so and some other ones are going to see at the end of what this topic. So please stay with us. Make sure you download the O3 Schools JAMB app because it is all you need to succeed in your examination. It has all the past questions you need. It has some wonderful features like the classroom feature where you can be learning, okay, while trying to attempt questions, answers to questions. Also, there's a wonderful feature called the question search feature where you can search for questions, okay, by topic, okay, and also UTME challenge is a bomb. Okay, you compete with your mates who are writing JAMB for this particular year. You are seeing your scores every week. Okay, you are seeing your score. You are attempting real JAMB questions. Okay, you are building your confidence towards the exam. You are winning prizes. So please, you do not have any reason not to have this app on your phone. Go to Play Store right now, download it, activate it. Don't be selfish. Activation is just 3,000 naira. As at the time of shooting this video, it will go up. It will definitely go up. So please pass your JAMB at once. There's nothing beats the joy of passing your exam at once. So any material you need to succeed, get it. So do not waste your time. Okay, 3,000 naira is too much. It's not too much. Okay, that's what you use to eat burger. So please sacrifice it. Download the app, activate. To activate, just click on activate on the app. And then at the top, you see where they wrote buy activation key. You'll see 3 options for activation. You can use your card to pay online and it will be automatically activated. You can transfer to the O3 Schools app account. Okay, after transferring, send the receipts to this number on WhatsApp 09121515246. After you have transferred the receipt of that transaction, just send it to this number on WhatsApp. Okay, or you can go to POS, make the payment, snap the receipt, send to this number on WhatsApp. Okay, you can call the number also, but you do not even need to call. Once you have sent the receipt, you'll be attended to. Okay, so please get the app. It is very useful to you, and I cannot stress it or I talk about it enough. Okay, so please we're going to looking at what this concept, and then we'll see some questions, and then we're done with this class. Okay, so when a metal rod, let's say we have a solution, when a metal rod like this, it's a metal rod, okay, is placed in a solution containing one of its salts. A metal rod is placed in a solution containing one of its salts. Let's say, for example, let's say a zinc rod, okay, put in a solution containing zinc sulfate 6. Okay, since this is sort of zinc. Okay, so if you place a zinc rod in this kind of solution, what happens? Okay, what happens is that some of the metal ions in this metal rod leave behind some valence electrons. They leave behind some valence electrons and go into the solution. Okay, what happens is that some of the metal ions, okay, in this solution, in this metal rod, okay, leave behind some valence electrons and go into the solution. Also, at the same time, some of the metallic ions, okay, pick up these electrons, these ions, and deposit them as neutral atoms on the metal rod. Okay, some of the metallic ions also at the same time, okay, pick up what these ions and what deposit them on the metal rod, okay, as neutral what atoms. Now, these two processes that I've just explained, okay, where the metal ion is what is leaving behind some valence electrons, while some other metallic ion are picking up those ions and what and leaving them as neutral atoms on the metal rod. These two processes that constitute what we call a reversible reaction, they do not occur at the same time. They do not occur at the same what rates. They do not occur at the same rate. So what now happens? What happens is that one of the metal rod and what and the solution becomes what positive. Okay, one of the metal rod and what solution of what the salt become positive, whereas the other one becomes what negative. Thus, what happened? A potential difference is now set up. You see that what as far as what you are not talking about positive and negative, a potential difference now was set up, okay, between what that metal rod and the solution of what of the salt. Now, the potential difference, okay, that is set up between the metal rod and the solution of the salt is what we call the what electrode potential. Electrode potential of that particular metal ion or metal system. Okay, of that particular metal ion or metal system. So a potential difference PD is set up between what the metal rod and what and the solution of what of a salt. Okay, now that potential difference that is set up between what that metal ion, okay, and what and the solution of his that metal rod and solution of his salt is called what the electrode what potential. Why the metal ion or the metal system itself, the metal ion or the metal system itself is what we call the half cell. The half cell. Okay, so it's as simple as A, B, C. Okay, so I'll go over that again. Okay, if what a metal rod is placed in a solution containing a salt, okay, like for example, zinc rod placed in a solution containing what? Let's say this is what the solution zinc sulfate. What to say is that what some of the metal ions, okay, in the metal rod will leave behind some valence electrons and go into the solution. While at the same time, some of the metallic ions will pick up what these ions and what and deposit them as what neutral atoms on the electrode. Okay, or sorry, on the what on the metal rod as we're discussing. Okay, and place them as what neutral atoms on what on the metal rod. Now you now see two processes, okay, which constitute what a reversible what reaction. Okay, now these two processes that constitute a reversible reaction, like I said, they do not occur at the same time or at the same what rate. Okay, thus what happens is that what one of the what the metal rod and what and the solution of the salt become what positive, while the other one become what negative. Because we now have what positive and negative, that means what a potential difference is now was set up between what the metal rod and what and the solution of what of the salt. Now that potential difference that is set up between the metal rod and the solution of the salt is what we call the electrode potential. While we say the metal ion or the metal system itself is called what the half cell. Clear? All right. Now, if this potential difference is measured using a mole per dm cube solution of what of the metallic salt. If this potential difference is measured using a mole per dm cube of the metallic salt at 25 degree was Celsius, which is what room temperature. At room temperature, as I was saying, if this potential difference is what is measured using what a mole per dm cube, 1 mole per dm cube metallic salt at 25 degrees Celsius, if it is measured at these conditions, we do no longer call it electrode potential again. We call it what standard electrode potential. Standard electrode potential, which is called what E naught. I hope that is clear. All right. Now, when two half cells are joined together, using what a salt bridge, when two half cells are joined together using a salt bridge, okay, using a salt bridge, we call what an electrochemical cell. electrochemical cell. Okay, when two half cells are joined together using what a salt bridge, we call that what an electrochemical cell. And now the difference between the electrode potential of the cathode and the electrode potential of the anode is called the EMF of the cell. EMF of the cell. The difference is the difference between what the electrode potential of the cathode, the difference between the electrode potential of the cathode and the electrode potential of the anode, okay, is what we call the EMF of the cell. Okay, so let me go over that again. Like I said if two half cells are joined together using a salt bridge, okay, let's say we have two half cells, this is one cell here, okay, with a rod, okay, then we now have another half cell like this, okay, if they are joined together using a salt bridge, okay, or you connect what a salt bridge from here to here, and then of course here we connect a voltmeter. Okay, so if two half cells are joined together, this is the salt bridge. Okay, where these ones are the two what half cell. Okay, now if two half cells are joined together using what a salt bridge, okay, we call that what an electrochemical what cell. We call it an electrochemical cell. Now the difference between the electrode potential of the cathode and the electrode potential of the anode is what we call the EMF. The EMF of the cell. Please take note of that. It's very, very important. Now, you can form a simple salt bridge, So you can form a simple salt bridge by what? By soaking a filter paper in what? In either sodium chloride, NaCl, or potassium chloride, KCl, even in what? In potassium nitrate. Okay, so you can what? Take a filter paper and soak it, okay, with what? Sodium chloride, KCl, or KNO3, and some other solutions, and of course you form what? Your simple what? Salt bridge. Okay, now the salt bridge, what is the usefulness of the salt bridge? The salt bridge is to enable ions to travel from one solution to the other. That is the usefulness of the word of the salt bridge. And then to calculate the EMF of the cell, like I said earlier, that the difference between two half cells is called EMF. Okay, that's what the electrode potential of the cathode and the electrode potential of the anode. So to calculate the EMF of a cell, what you simply do is to find the difference between the electrode potential of the cathode, electrode potential, I've written that before, electrode potential of the cathode minus the electrode potential of the anode. Okay, so one important thing you should know is that oxidation occurs at the anode. Oxidation occurs at the anode. Okay, just keep that at the back of your mind. All right, so now what I'm saying, to make a salt bridge, simply soak a filter paper with sodium chloride or potassium chloride, or even potassium nitrate, okay, and you have your salt bridge, this connection, okay, and the salt bridge enable ions to travel from one this way, okay, from one solution to the other. Okay, this is your simple voltmeter here. Okay, so now having seen this, what next should we know? So now it's important to know that this formula, this electrode potential of the cathode minus the electrode potential of the anode, can still be translated to be equal to what now? EMF is equals to what now? ERHS minus what? ELH That means if an electrochemical cell is to be arranged properly, okay, the cathode will be on the right hand side while the anode will be on the left hand side. Okay, that's why I'm saying ERHS minus what? ELHS. Okay, I'll go over that again. So for this, it will mean that the cathode will be on the right hand side if an electrochemical cell is to be arranged accordingly. okay, properly, that means what the cathode will be on the right hand side while the anode will be on the left hand side. But of course, like I've hinted earlier, that what oxidation occurs at the anode. It occurs at the anode. Okay. Now, by this arrangement, it means that what that the EMF will be positive. By this arrangement, it means that what that the electromotive force EMF will be what will be positive. Now, there are some important things we need to now know. Okay, this condition we call what spontaneity. Okay, so for spontaneity, EMF has to be what positive. Okay, please, you must take note of this. For spontaneity, EMF has to be what positive. Okay, why what delta G, the Gibbs free energy, we call it the free energy, or Gibbs free energy has to be what negative for spontaneity. For spontaneity, delta G has to be what negative, while what EMF has to be what positive. Okay, so now, but if EMF, this is for spontaneity. So if EMF is negative, okay, so for that we say what it is non-spontaneous. Non-spontaneous. Okay, if EMF is what is negative now, okay, and then delta G is what is positive, we say well that system is not what spontaneous. Okay, so this is for spontaneity. EMF is positive, delta G is what negative. Okay, for non-spontaneous system, EMF is what negative, delta G is what is positive. Okay, but if delta G is equals to zero, we say what that system is in what is in equilibrium. It's in what? It's in equilibrium. So you must take note of that. Also, it is important to note that there are some formulas that we use to look for what? For delta G. Delta G itself is what? It's free energy. Okay? We call it the Gibbs free energy. Okay, so there's a number of formulas, like 3 I'm going to list for you now. When we start talking about Gibbs free energy itself, energy that's available for use, okay, we're going to do some calculations on them. But for now, just note what this formula. We're going to use one of the formulas to answer some of the questions from the app. Okay, so how would that delta G is equal to what? Minus NFE. Okay, where N is number of what? Moles of electrons, where F is what? Is Faraday's constant. Okay, they also have that delta G is what? Is RT ring K, or you can say KD. Okay, where what? R is what? Molar gas constant. You know the value 8.314. You know the temp T is what? Is temperature in Kelvin. Is temperature. Okay, and then KD itself is what? Dissociation rate. Okay, so then of course we also have another formula. That's what that delta G is what? Is delta H minus T delta what S. So this last one, delta H there is what? Is change in enthalpy. Delta H change in enthalpy, T is temperature, while delta S is what? Change in what? In entropy. Okay, we're going to be using this third formula very well as we start talking about taking questions from the O3 School JAMB app. Okay, also, quickly, before we end this class, it will be bad for me if I fail to show you how two half cells are joined together. Okay, so let's say we have two half cells, a zinc half cell and a copper half cell. Now let's see how they are how the overall EMF of the cell is calculated. Okay, then of course let's say we have don't mind my drawing. Let's say we have two half cells. Okay, this is let's say a zinc rod. Okay, Zn, zinc inside Zn SO4. Okay, let's say yes positive, then yes negative. Okay, then we now have another rod here. It's a copper rod in copper sulfate solution. Yes, let's say it's positive, yes negative, and so on and so forth. Okay, now then to draw the complete circuit, you know that you need what to call a salt bridge. A salt bridge is what enables a ion to travel from one of the solution to the other one. Okay, so we need to connect our salt bridge. So our salt bridge is connected like this. This is our salt bridge. We call this our salt bridge. Now, after having our salt bridge, it is not done yet. Okay, we also need what? Because a potential difference has to be set up. Okay, so we need to connect what? A voltmeter. Okay, so we can have what? A voltmeter connected like this V. Okay, into what? Into the cells like this. Okay, so our setup is complete. Okay, so we know that what? This is of course the anode. This is the anode. Okay, and this is the what? Is the cathode. Like I said, that what if what an electrochemical cell is what is to be properly drawn, we're going to have the anode on the left and the cathode on the right. Okay, so this is what our setup looks like. And of course, we know that oxidation occurs at the what? At the anode. So because oxidation occurs at the anode, let's say you are going to have what this will be the reaction Zn and will give us Zn2 plus 2 electrons. Why for this? Because reduction happens here. We're going to have Cu2 plus 2 electrons to give you what? Cu. Okay, solid. Okay, so this is what the reaction. Okay, so please, as you can see very well, this is a salt bridge. And if you want to represent what this in an equation, one can say that what that Zn, okay, Zn2 plus, okay, then can I have what Zn, okay, sorry, now have Cu2 plus Cu. Okay, this is what this is showing what that I have what two half cells of zinc and what and copper. And this sign here, this double sign, double slash you are seeing here is called the salt bridge. It's called the salt bridge. And I remember very well that I told you that what to make a salt bridge is just to what soak a filter paper in what in sodium chloride or potassium chloride or even potassium nitrate or even sodium nitrate. Okay, so that's how we can make what your salt bridge. Okay, then can I calculate the overall EMF of the cell? And I told that EMF is what is usually what positive for spontaneous reaction. So that EMF is usually what positive for spontaneous what reactions. Okay, and of course it is if it is non-spontaneous, that means EMF is what is negative. Okay, I've stressed about that. So now what I'm going to do is to just go to the past questions immediately and start what answering them. Okay, so now open your O3 School JAMB app. As like I said, it's a requirement for this class. You must have it. It's something you must have because it is useful to you. Okay, let's see the app. So I've opened my app here. Sorry. Okay, let's see. So I given a first question here. They said, what does a negative value of Gibbs free energy delta G indicate for a reaction? It's being shown on your screen. This is a 2023 question. In case you are mistaken, it's a 2023 question number 3. They say, what does a negative value of Gibbs free energy delta G indicate for a reaction? We have seen that what when delta G is negative, it means the reaction is what? Is spontaneous. It means the reaction is what? Is spontaneous in the forward direction, okay? Or in the forward what reaction. Okay, so now they said that well, a reaction is non-spontaneous and requires an input of energy to proceed. It's very wrong. Okay, they say B, the reaction is spontaneous in the forward reaction, in the forward direction. Very correct. They say C, the reaction is at equilibrium. Now, when delta G is what is 0, then you can say the reaction is at what? Is at equilibrium. Okay, then if delta G is positive, then we say it is what? Non-spontaneous. All right, so we have established those. Okay, so that means our correct answer there will be what? Will be option B. The reaction is spontaneous in the forward direction. Okay, now let's see another question. This is a 2023 number 26 is being displayed right now. They say, in which type of cell does electrolysis take place? Please know that electrolysis takes place in an electrolytic cell. In an electrolytic cell. That's where electrolysis what takes place. Please take note of that and have peace and no peace. Okay, let's see another question. They say, which of the following conditions will mostly enhance? Look at it very well. This is a 2019 question. A 2019 question. Which of the following conditions will mostly enhance the spontaneity of a reaction? It's a 2019 question number 26. Which of the following conditions will mostly enhance the spontaneity of a reaction? A, we're given that what? Delta H is negative and greater than T delta S. That means from this formula, it was from this formula that giving us for that question that delta G is equal to what now? Delta H minus what? T delta S. Okay, now to get the correct answer here, all right, we need to what? Assume some parameters. So let's say, for example, that delta H is 300. Okay, and let's say that T delta S is 200. Okay, let us see option A now. Option A says delta H is negative. If delta H is negative, I'm going to have minus 300. Okay, then minus what here? Then they say and greater than T delta S. So 300 is greater than T delta S, right? So I'm going to have what? Minus 200. So I'm going to have minus what? 500 here. You understand? Just keep that at the back of your mind. Then the second option says that delta H is what? Is negative. Since delta H is negative, I'm going to have minus 300, then minus, and delta S is 0. They say delta S is 0. If delta S is 0, then delta S times T is what? Is 0. If delta S is 0, 0 times T is what? Is 0. That means I'm going to have minus 300 minus 0, which is what? Minus what? 300. Okay? Here, minus 300 minus 200 is minus 500. Those of you that did mathematics, those of you that not jump fence, that not scale the fence, go and pluck mango, or to go to another class that are teaching another thing. Okay, even if that stayed in math class, you should be able to understand this simple word addition. All right. So now, C tells us that delta H is positive. If delta H is positive, then we're going to have 300, then and equal to T delta S. Then minus what now? Minus 300. 300 minus 300 is what? Is 0, because they say delta H is positive and it is equal to T delta S. We want to have 300 minus 300. Now D, we are told that what? Delta H is positive, that is 300, and less than T delta S. That means they're saying T delta S is greater than what? Delta what? And delta H. So let us say delta T delta S is 400 here. Minus 400, I'm going to have what? 300 minus 400 here will be what? Will be minus 100. All right. So that will be the value. 300 minus 1 minus 400 minus 100. So now let us see these conditions and see which one satisfy, which one is the reaction most enhanced. Which of the following conditions will most enhance the spontaneity of reaction? If delta G is negative, it is spontaneous, right? Okay. And then if it is 0, it is at what? At equilibrium. Okay, so this is positive, this is negative, this is negative, this is also negative. Now, the more negative delta G is, the more spontaneous the reaction is. Okay, so that means our correct answer here, because as you can see from the question, they say which one will most enhance the spontaneity. So, of course, option A will be our most correct answer for that question. All right, so we're given another question again. It's a 2009 question, number 25. 2009, number 25. Okay, so we are giving a reaction between carbon and steam. Okay, steam reacting with H2O to give you H2 plus what? Plus CO. All right, so they say delta G for this reaction is minus 43 kilojoule. Okay, so since we are knowing already that delta G is what? Is negative, that means we know that the reaction is what? Is spontaneous. Okay, we mean that the reaction is what? Is spontaneous. Let us see the option. They say at this temperature the reaction is what? A, not feasible, which is wrong because it's negative. So it is feasible. It is feasible. It is spontaneous. Okay, it will produce in the it will proceed in the what? In the forward direction. Proceed in the forward direction. It is what? It is be spontaneous in the forward direction. Okay, so we already know this condition. So they say B at equilibrium. No, delta G is not 0 here, it's minus 43. That's the value, so it will not be at equilibrium. Then D, they say exothermic. Okay, so that is even a different thing entirely. So our answer there will be what? Option C. So we have so many questions on this app also. Please go and download the O3 School JAMB app immediately right now. Then click on activate. Go to buy activation key, purchase activation key, and start practicing. You do not have time. You do not have time to check time. And I'll see you in the next class. Thank you for watching.